Types of chemical reactions by Caroline Stockdale, second period. Here are the definitions of all of the chemical reactions. Synthesis. A synthesis or combination reaction is when there are two sets of reactants that come together to produce one product on the other side. Synthesis would be the star plus the heart goes into a star heart. Decomposition. A decomposition reaction is when a single compound is divided into two different elements or compounds. This is the separation reaction. Decomposition would be the star heart yielding into the star plus the heart. Single replacement. A single replacement reaction is when one has a compound plus an element that yields to another element plus compound. The element is switched out on either side by putting a single element into a compound.
Single replacement would be the star plus the heart smiley face goes into the heart and then the star smiley face because the cations have switched.
Double replacement. A double replacement reaction is when one has a compound plus a compound that yields to another compound plus a compound. The cations and anions of the two different molecules are interchanged to form new compounds on the other side. Double replacement would be the star heart plus the smiley face swirl yields to the smiley face heart star swirl because, again, the cations have switched here, as you can see. Combustion. A combustion reaction always includes carbon, hydrogen, and oxygen. The reactants always yield to create water on the product side, or the other way around. When this reaction occurs, heat and light are formed. It also creates carbon dioxide. Here are the chemical reactions. So now we have our synthesis reactions. So looking at number 1, we start off with amide, which is 1 nitrogen and 3 hydrogen. And so looking over here, we have 2 nitrogen because the 2 carries on over there. And so to fix that on the reactant side, we need to put a 2 in front of this. But now that we have the 2 in front of there, it also goes to the 3. And so now we have 6 hydrogen plus the 2 hydrogen over here. So looking over here, the 4 times the 2 is the 8. So now we have 8 hydrogen on both this side and this side. Right here we have hydrosulfuric acid, and so that is the 2 hydrogen that we have added with that to equal the 8, but we have 1 sulfate. So over here we also have 1 sulfate, so we're fine with that. And so that is our first balance reaction, now that we have added a 2, a 1, and a 1. Now we're going to work with our second equation, and so this one is nitrogen plus hydrogen yields amide. So looking at our first nitrogen, we have 2 right here, but if you go to the product side, you only have 1. So to fix that, you need to multiply a 2 in front of the NH3. So now that we have the 2 that is multiplied by the 3, we also have 6 hydrogen on this side. And so to fix that on the reactant side, since we started with hydrogen 2, we need to multiply that by 3 so that we have 6 on both sides. And now we have a balanced equation whenever you add the 1 in front of the nitrogen, the 3 in front of the hydrogen, and then the 2 in front of the amide. So looking at our last synthesis reaction, we start out with magnesium plus oxygen yields magnesium oxide. So right here we start off with 1 magnesium, and we also have 1 magnesium over here, so we don't need to do anything with that. And over here we have oxygen 2, but the only reason it has a 2 is because it's a diatomic element, so it's really just 1 so that it doesn't have to be by itself. So over here we have 1, and so we don't have to do anything to that equation, so it is already balanced. For our first decomposition reaction, we start off with mercury oxide, and it yields to mercury plus oxygen. And so right here we have 1 mercury and 1 mercury, and then we have 1 oxygen and 2 oxygen as it looks like, but it only has the 2 there because it's a diatomic element and it can't be by itself, so there's really just 1. So that's balanced. And then for number 2, we have magnesium chloride yields magnesium chlorine. So right here we have 1 magnesium and 1 magnesium. And then over here we have 2 chloride and 2 chlorine. So basically it's already balanced. You don't have to do anything. Then for this one you start off with iron sulfide yields iron plus sulfur. So right here we also have 1 iron, 1 sulfide, and 1 sulfur. So those are all single replacements. We have chlorine plus sodium bromide yields sodium chloride plus bromine. So for this one we have the chlorine, it's technically 1 because it's a diatomic element. And we have 1 over there, so we're good with that. And then we have 1 sodium, 1 sodium. And then over here, we have 1 bromine and then 1 bromine over here because it's a diatomic element, so it has to have the 2 there. So it's balanced. For this one, we have 1 iron and 1 iron, so that one's good. And then for the hydrogen, we technically have 1, and we have 1 over here because it just needs the 2 because it can't be alone. And then for the chlorine, right there we have 1, but over here we have 3 because that is how the charges of iron had 3 and chlorine had 1. And so whenever you set up the ratio, this one ended up having 3. And for this one, I also had to add numbers in front to balance it out. And so over here we have 3 lead, and we have 3 lead right there. Right here we have 6 hydrogen, and we have 6 hydrogen there. And then we have 2 sets of phosphate, and over here we have 2 sets of phosphate. So that one is balanced as well. For the double replacement on number 1, we start off with lithium nitride plus ammonium nitrate yields lithium nitrate plus ammonium nitride. So we start with 3 lithium over here, and we have 3 lithium over there. For nitrogen, we have 1 plus the 3 there, so that's 4, plus another 3 there, so that's 7. So we have 7 on this side. This side, we have the 3 right there, so that's 3, plus the 3 right there, so that's 6, plus 1, so that's 7 now. For the hydrogen, we have 4 times the 3, so that's the 12. And right there we have 4 times the 3, so that's the 12. And then for the NO3, which is the nitrate, we have 3 right there and 3 right there. So those are all equal. That one's balanced. For this equation, we have sodium bromide plus calcium hydroxide yields calcium bromide, and plus sodium hydroxide. So we start off with 2 sodium, 2 sodium, 2 bromine, 2 bromine, 1 calcium, 1 calcium, 2 hydroxide, and 2 hydroxide. So that one's balanced. And then this one, we have aluminum bromide plus potassium sulfate plus potassium bromide plus aluminum sulfate. So we have 2 aluminum, and then we have 2 aluminum. We have 6 bromine, and we have 6 bromine. We have 6 potassium, 3 sulfate, and 3 sulfate. So those are all balanced. Okay, so for combustion, just looking at the end of these problems, they all 3 yield carbon dioxide plus water, so that's how we're always going to know that it's combustion. So for this first one, we start off with 1 carbon, we have 1 carbon. We have 4 hydrogen, and the 2 times the 2 is 4 hydrogen. We have 4 oxygen over here, and then the 2 plus the 2 equals 4. So that one is balanced. For this problem, we have propane plus oxygen yields carbon dioxide and water. So we start off with 3 carbon, now we have 3 carbon over there. We have 8 hydrogen, and then 8 hydrogen there because of 4 times the 2. Now for the oxygen, we have the 5 times the 2 over here, so that's 10. And then we have the 3 times the 2, which is 6. And then the 4 over here, and so 4 plus 6 is the 10 that we need. So that one's balanced. And then this one, we start with methane plus oxygen yields carbon dioxide plus water. And so we start off with 1 carbon, 4 hydrogen, 4 oxygen, and then 2 oxygen there equals the 4 oxygen. So those are balanced.